Welcome to Unit 1. This is IPC Physics semester, and we're looking at the guided practice as part of your remediation packet. And so we're going to go over some academic vocabulary because we're going to see it later on in everything else. So in the first one it says define the following terms. Length. Length is the measure from one point to another in a straight line. It's how long something is. Length is measured, the standard unit for length is measured in meters. And we see that we have, after that, we have displacement. Now displacement is the distance from, or the length from the very start to the very finish in a straight line. Displacement is different than distance. Distance is how much you travel, but displacement is the start from the very beginning to the very end in a straight line. A conversion factor. Conversion factors are used to convert between one unit to another. So if we want to go from centimeters to meters, we need a conversion factor. Speed. Speed is a scalar quantity, meaning it is the rate at which something is traveling over a distance. And velocity. Velocity is a vector quantity, meaning it is similar to speed, but velocity also includes a direction, so where it's going. And we use the word vector scalar when we describe speed and velocity, because vector is a number plus a direction, and a scalar quantity is just a number. It's just an amount, it's a magnitude. And then lastly, we have acceleration, or not lastly, but getting towards the end, acceleration. Acceleration is the change in velocity all over time. We can accelerate or deaccelerate. And then we have final velocity, which is the velocity at the very end, and initial velocity, which is the velocity in the beginning. Those are some good vocabulary that we'll need to help solve some problems. So starting in our first section, this is distance versus displacement. We talked about those two definitions just a second ago. So in the first question it says, if you walk around a 400-meter track completely one time, what is your displacement and distance traveled? So if we have a track, and this is like a track where you actually run, so we have a track, we start right here, we go all the way around, we finish right here. So displacement is the distance between the beginning and end, and so the displacement would be 0 because you started and finished in the same spot, but your distance that you traveled is the whole length of the track, which is 400 meters. B says explain the difference between distance and displacement. So distance is the amount traveled. If you're walking, if you're moving, then you're going a distance. Displacement, though, is a straight line from where you start to where you finish. And C, determine a scenario where distance and displacement would be equal. Think about traveling in a straight line. If we travel in a straight line and we just go forward, we don't go backwards, then we will have the same distance and displacement. Looking at metric conversions, anytime we convert, we need a conversion factor, and we are converting to standard units, which standard units is meters. So on the first one we have 12.5 millimeters, and we're going to meters, and there is 1,000 millimeters in 1 meter. So 12.5 millimeters. Set up dimensional analysis, and all we'll do is we'll put 1,000 millimeters equals 1 meter. And so essentially all we're doing is dividing by 1,000. So we'll get 0.0125 meters. Next we have 19.8, so we need a conversion factor. It's centimeters, so 100 centimeters equals 1 meter. So 19.8 centimeters. Set it up. Centimeters would go on the bottom, meters would go on the top, and so we're dividing by 100, so 0.198 meters. And then lastly we have 7.9 kilometers, and this one, 1,000 meters are in 1 kilometer. So we have 7.9 kilometers and we put kilometers on the bottom, meters on the top. And we're multiplying by 1,000 here, so we have 7,900 meters. Now, looking at a distance versus time graph, we know it's a different distance versus time because it says distance and it says time. It's a distance versus time graph. On A, it says what time will the ball reach 5 meters. So if this is a ball moving on a track, we look at 5 meters. It's right here. What time will it take? Right there, which that's right around 1.5 seconds. All I did was went right there, then go straight down. And next one, it says how long will it take to travel 40 meters. So find 40, all the way over, go straight down, 5 seconds. And our last question, what is the average speed between 0 and 1.5 seconds? So 0 is right here, has 0 velocity, and then 1.5 seconds is right there. And so it's looking at the average velocity is just the slope of this line. So it's y all over x, so it would be 5 over 1.5. And when we get that, 5 divided by 1.5, 3.33 repeating meters per second. We're talking about speed. We're using the equation speed equals distance all over time. And when we solve this, if we're solving for the unknown variable, all we have to do is plug it into that equation. So on this one, we're solving for speed. So it's just 10 meters, which is the distance all over time, which is 5 seconds. So we'd have a speed of 2 meters per second. On the next one, we have to do a little bit of rearrangement because we're solving for time. So what we would do here, we would use the equation time equals distance all over speed. And so all we would do is have our 5 all over 2, and we would get an answer of time of 2.5 seconds. And lastly, we're solving for distance, so we would use the equation distance equals speed times time. So we have 3 times 1.5, which would be 4.5 meters. Looking at velocity versus time graph, we know it's a velocity versus time graph because it's velocity and it's time. And it says what is the velocity at 7 seconds. So all we have to do, find 7, go up, find our velocity, which is 50 meters per second. Where are they accelerating? Where's there an acceleration? Anytime there's an acceleration, we have a slope on this line. So here we have a slope. So from right around a half a second all the way to 5.5 seconds we're accelerating. Deacceleration, so C, would be when the slope is negative, going down in this direction. So a very short time, about 7.5 seconds to about 8.5 seconds. Now looking at the acceleration equation, solving for the variables, the unknown variables. Acceleration equation, remember that acceleration equals velocity final minus velocity initial all over time. So this, what we're going to have is we're going to have our final velocity minus initial velocity. So 2.3 minus 1.2 all over 5 seconds. And we get an acceleration of 0.22. And this would be meters per second squared. In our next problem, we're doing the same thing using the same acceleration equation, but this time we have a final velocity of 1.3, initial velocity of 2.2, and 3 seconds, plugging those variables in. And what you should see is you get a negative acceleration of 0.3 meters per second squared. And lastly, see if you can rearrange the equation. You're solving for time, and the answer that you should get is 0.467 seconds.